All right, let's talk about the invisible engine that powers pretty much our entire digital world. It's a piece of tech you rely on every single second of the day, but you've probably never really thought about it. It's called NAND flash memory, and it's high time we dug into what it actually is.
So, let me kick things off with a quick question. What could your phone, your laptop, and get this, the traffic lights at the corner of your street possibly have in common? I mean, they seem totally unrelated, right? But believe it or not, they all hinge on the exact same piece of technology. And the answer is, you guessed it, NAND flash.
Okay, so here's our game plan. First, we'll see how NAND is basically inside everything. Then we'll get into what it actually is. After that, we'll explore the solid-state revolution it kicked off, take a peek at how the magic works, and finally, we'll look at what's next for flash memory.
So let's jump right into section 1, the memory inside everything. And really, it's no exaggeration to call this stuff the unsung hero of your digital life.
I mean, just think about the sheer range here. The obvious stuff is on the list, of course, our phones, laptops, and all those USB drives. But it's also running our cameras and memory cards. But here's where it gets kind of wild. It's also controlling traffic lights, those giant digital billboards you see, even the announcement systems in airports. Basically, if something needs to store data and get to it fast without being plugged in all the time, chances are it's using NAND flash.
Okay, so it's everywhere, we get that. But what is this stuff? Let's get down to the core definition of a technology that, and this is not hyperbole, truly changed everything.
At its heart, NAND flash is a type of non-volatile memory. Now that sounds pretty technical, but it really just boils down to two super important things. First, it holds onto your data even when you shut the power off. And second, it's built from the ground up for two things, speed and capacity. It's all about storing and grabbing huge amounts of data, like really fast. Let's just focus on that non-volatile part for a second, because that is the absolute secret sauce. You know how the RAM in your computer gets total amnesia the second you unplug it? Poof, everything's gone. Well, NAND is the exact opposite. It remembers. It's the whole reason you can turn your phone off for a week, turn it back on, and all your photos, apps, and messages are still sitting right there, perfectly safe. And that one feature, that ability to remember, is what sparked the solid-state revolution. You see, this wasn't just some small improvement over what came before. This was a completely different way of doing things. Just look at this comparison right here. Before NAND-based solid-state drives, or SSDs, we were stuck with these old-school hard disk drives, the HDDs. Think of them like tiny little record players, with spinning platters and an arm that had to move to find your data. They had moving parts, which made them super fragile. You drop your laptop and you could be in for a very bad day. NAND has zero moving parts, it's solid. And the speed? It's not even a contest. This is the difference between your computer taking minutes to boot up versus just a few seconds.
And the list of superpowers just keeps going. Portability? NAND lets you pack an unbelievable amount of storage into a tiny space. It's also way more power efficient, which is why our batteries last so much longer now. It's reliable, it's tough, the cost per gigabyte just keeps falling. And, one of my favorite parts, because there are no moving parts, it's completely silent. No more whirring and clicking.
Okay, so we've established that it's pretty amazing. But how does it actually do what it does? Let's take a quick peek under the hood. I promise it's less like magic and more like some really clever physics. The whole thing boils down to this one component, just repeated billions and billions of times, the floating gate transistor. The easiest way to think about it is like a microscopic light switch. But instead of turning a light on and off, it traps a tiny electrical charge that represents a single bit of data, a 0 or a 1.
So how do you flip that tiny switch? Well, it's kind of a three-step dance. To store data, you hit it with a high voltage that literally shoves electrons into a little trap. That's how it stores a 0. To read the data, a sensor just checks, hey, are there electrons trapped in there? And to erase it, you hit it with a reverse voltage that flushes all those electrons right back out, resetting the switch to a 1.
Now this brings up a really interesting quirk. Unlike an old hard drive that could go in and change one tiny bit of information, NAND has to erase data in big chunks called blocks. Think of it like a notebook. A hard drive could erase and rewrite a single word. NAND has to erase the entire page and then rewrite everything you wanted to keep. Now don't worry, there's a really smart controller chip that manages all of this in the background so you never even see it happening, but it's a fundamental part of how it all works.
All right, let's wrap up by looking ahead to the future of flash, because this story is nowhere near over. In fact, it's just getting faster. The goal is simple: pack more data into smaller spaces, and do it for less money.
And one of the main ways they're doing this is by getting each of those tiny little switches to hold more information. It started with what we call single-level cell, or SLC, which held just 1 bit. Super fast, super durable, but really expensive. Then came MLC, TLC, and now QLC, storing 2, 3, and even 4 bits in the exact same cell. Every step makes the storage bigger and the cost lower, which is exactly why you can buy huge SSDs today without breaking the bank.
But the other massive, mind-blowing leap forward is 3D NAND. For years, engineers were just trying to shrink everything and pack it closer together on a flat 2D plane. But they literally hit a physical wall. They couldn't make things any smaller. So, the solution? Go vertical. 3D NAND stacks memory cells on top of each other. It's like building a skyscraper instead of a sprawling suburb. This lets them achieve insane increases in density and capacity.
So to bring it all home, what are the big things to remember? 1. NAND is the non-volatile memory that keeps your data safe in everything from your phone to a traffic light. 2. It's the technology that killed off slow-spinning hard drives and made our devices faster, tougher, and more efficient. 3. It all works by trapping tiny electrical charges in billions of microscopic switches. And 4. It's a technology that is just relentlessly evolving to get denser and cheaper every single year. And that kind of leaves us with one final big question. We are creating a truly staggering amount of data every single day. For now, NAND flash is the bedrock holding all of it up. But as that data explosion continues to accelerate, you have to wonder, what comes next? What's going to be the next leap forward for the memory that stores our entire world?